Where are we? Presenting slides again. All right. So let's get into something a little bit better. We talked about calculators. We talked about calculators having memory. Well, computers have memory too. And in computers, you have a lot more of them, and you can name them. And those names are these kind of variables. So how do I want to do this one? Hopefully this is still legible down in the little corner there. But let's take a look at the whiteboard and hope that our whiteboard battery doesn't wear out. Let's say we have a cylinder of radius, and the radius is, and that is a permanent marker. We don't want to use that one. Radius is 2, and the height is 10. And what we want to do is we want to go through and we want to calculate a bunch of things on it. In particular, what we want is we want the volume and the surface area. Along the way, we're going to calculate a base area, and we're going to put in a value for pi, radius, and height. Okay? So if we start off in our handy-dandy spider, right, we can come in here and we can type something like, and I have these all too far. I typed in too many things since then. I can type these in like pi equals 3.14159. Right? And what this does is it takes the value 3.14159, of which I only have a few digits, and it puts it into a memory location that has the label pi. Okay? So pi is a variable. What pi references is it references some place in memory, and that place in memory now has a float value 3.14159, as many digits of pi as we want to put into it. Okay, and that's what the meaning of this equals is. It's take whatever is over here and find, either create or find a memory that's labeled pi and put that value, store that value at that place. Right, and we can do this multiple times. So we'll do that with pi. We'll do it with radius. Right, radius is 2. That's the radius of our cylinder. Right, and now the memory location labeled by radius now holds the value 2. By the way, if this were a live lecture, I would be doing this with balloons, and I would have volunteers. It's not nearly as much fun to pop a balloon when I'm the only one in the room. I can't see you guys jump. All right, and then we can do the same thing with height. Still got to go all the way back there. At some point, I think I'm just being lazy. Right, and now height has the value 10. Now we've actually captured the physical bounds of our system. And if we want, we can come in here, we can look at these. We can say, what does pi equal? Well, pi is 3.1459. That should be 159. Fat finger syndrome. Okay. 3.14159. Radius is, and all we're doing when we're entering these is we're just asking it to tell us what's stored at those locations, right? So 3.14159, radius 2, height of 10. And now we can start doing some calculations. Well, if we want the volume and surface area of a cylinder, they both rely on this base area, right? Where the base area is, well, the area of this disk, right? The surface area of that disk. For the volume, we're going to take that surface area and multiply it by the height, right? That'll give us a volume. For the surface area, well, this is one of the end caps. There's another one down here. So the surface area is going to be 2 times the cap area. And then we have to unwrap this cylinder, right? If we kind of split it, unwrap it, the height is still going to be 10, and the length is going to be the circumference, right? So the circumference would be 2 times pi times the radius, and the height would be 10. So if we can calculate that end cap, it's going to get us a long way towards getting our values. So we'll set up another variable, base area, to calculate this intermediate value we need, and that's going to be pi times the radius squared, right? So when we execute this command, what we're saying take everything here and take whatever value is there and put it into a piece of memory labeled with base area. Okay? So we look at it and we see pi. Pi isn't a number, but pi labels a piece in memory. So it takes whatever values in that memory and plugs it in here. And then it takes whatever value is stored in the memory location radius and plugs it in here, right, which is our 2. And then it does this calculation and stuffs it into base area. So if we look at what's in base area, we should be able to see that this should be somewhere around 12.5 or something. 12.56636. These are small pieces of paper instead of very large balloons. So we will approximate that with 12.56. So now we have 4 values stored in memory in labeled memory locations, right? Places we know. One is pi, radius, height, and this base area. And now we can take this further and we can use any of those values to calculate, for example, the volume. Right? The volume is the base area times the height. Right? So 125 and change. So 125.7. That gets shoved into volume. And now we have the final one, which was surface area. This is a little more complicated. Surface area is, like I said, twice the end caps. Plus, well, now we have to find the circumference of an end cap. So it's 2 times plus the area of the end cap, 2 times, or the circumference of the end cap, 2 times the radius, times pi. Right, so that gives us the circumference, and then we have to multiply that by the height to get the skin of the cylinder. And if we look at surface area then, and I didn't mess that up because that was a lot of typing in a row, that should come out to be about 150.8, and that gets shoved into surface area. Okay? Now, here's the interesting thing. We've just gone through a sequence of calculation. Actually, before we do that, we may want to report on this. In the console, if you want to know the value of something, we can just ask for it, right, like volume. And get it, but we may want to nicen it up, or maybe we want to do it from a file over here, like Hello World. So maybe we have to print something out, something like, I'm not going to bother being exact because, yeah, maybe I can be exact. Volume is volume, and surface area is area. Okay? And when we execute this, the same thing is really going to happen. These are strings. They're the third type we're going to kind of mention today. We'll go into them in more detail later, but they just represent some text, right? So the print statement is going to print out that text. It's going to find the value of volume, right, which is there, and substitute it in where it sees volume. It's going to print out the string surface area is. It's going to find the value of surface area right down here and pull that in. Oh, I know what that is. Okay. And then it's going to print them all out, and it's going to come up with something like that. Okay, now what happens, right? We've been doing this, and we've done a sequence of calculations. One thing I want to point out is, let's say we change something, like let's say the height of the cylinder is no longer 10, but let's say it's 15. Okay? If we do our print, nothing else changes. Because what happens is we have changed one value from 10 to 15, but we haven't actually told the computer to go and change any of the other values. It's not remembering our sequence of operations, right? What it's doing is it's just doing exactly what we tell it to do. We told it to put 15 into height. We didn't tell it to recalculate anything else. If we go back through now and recalculate volume, right? Well, then volume is going to change. Surface area still hasn't changed. If we go through and now recalculate surface area, only then will everything be up to date. So just be aware that changing one value in a string of calculations has no impact on anything else that you've stored. So it's a little, buyer beware kind of warning, I guess. All right, what else do we want to talk about? I got through that. Got through that. We did the print. We'll talk a lot about print, by the way. This is a very early, very easy introduction. We'll get a lot more into print because all of your Submiti stuff is going to have to be printed out, and it's going to have to match what we're expecting to see on Submiti, which is both an exercise in precision on your part and necessary for the way we're actually doing the grading. All right, so quickly let's talk about variable names. I think that's the next topic here. Come on, there we go. You have to coax your computer every now and then. Nice words like good job helps out immensely. Okay, variable names. You'll notice we have a bunch of variable names. We have, like pi, pi, radius, radius, height, base area, base underscore area, volume, surface underscore area. So you can build a variable name in Python. Different languages have different rules, but you can build a variable name in Python with a combination of letters. Upper and lowercase are different, right? So lowercase surface is a different variable than uppercase surface. So if we said surface area, right, we get something. If we do surface area, we don't, right? That variable has not been defined yet. And by the way, at one point, it's going to ask you what happens in this lecture. It's going to ask you what happens if you reference a variable that hasn't been created yet. Well, this is what happens. You have to create a variable by assigning something to it before you can actually use it. Oh man, there has to be. I think I can automate this next time. Okay. Yeah, and it looks so good when I'm talking. So here's surface area, right? Our surface area is 213.62812. But if I try to print out surface area in caps, we get a name error. Surface area is not defined. Name error is a type of syntax error. It'll stop your program from running. In order to actually do something, we have to do surface area. We have to assign something to surface area, and that creates the variable, and then you can actually access it. Okay. Otherwise, you're essentially accessing uninitialized memory. Is the error you'll get in other languages. All right. So now I'm going to switch back to presenting slides. What I need is I need like an electroshock collar. You guys can just biz me every time I'm not showing what I'm talking about. Okay, so variable names. Variable names include letters, the underscore characters, and you can also have numbers, digits from 0 to 9, or 11, or any combination of those digits. There are a few rules. You can't have a digit to the start of variable, so you can't have something like you can't have something like 1a, right? 1a equals 7, for example. And that's because the way the interpreter works is it has to parse this, and it has to figure out whether it's a number or a variable, and the 1 confuses it. So we just say you can't do that. It's a feature of the language to make this parsable, to make this able to be processed. So 1a won't work, but a1 will work. And underscore a1 will work as long as I assign it to something, right? A underscore 1 will work, right? The only rule is that I think even underscore 1 will work, right? So the only rule is that the rules are you can use underscores, letters, and digits, right? We can use all the digits if we want. Underscores, letters, and digits. The first one has to be either a letter or the underscore character itself. If it's a space, something else, it signals the end of the variable name. So, for example, I always like to put spaces in because I think it's more readable, but you don't have to use spaces because that equal sign is not one of the permitted letters. And I'm going to cheat. I can't type that again. Right, so as soon as it hits that equal, it decides that it's done. And like I said, capital letters and small letters are different. Let's see. We've done all this in the interpreter. We did this intentionally in the interpreter. Last time I showed you files. We can do the same thing to put this in a file. So if I come into, I don't get the electroshock this time. I'm doing this intentionally. Right, we can put all this into a file, get rid of the garbage characters at the front. I just cut and pasted this from the document so I didn't have to type it again. And then save this, get rid of that line. Save this as temp.py, that's good enough. And then run it, and this should give us, that last line is the output, not the program. All right. Right? We can put it in a file, then execute the file, and that will give us the same answer. All right. So we'll work over here when I'm doing exercises in class because it's convenient. This is a good place to play around if you're trying to figure out syntax or if you're trying to work through some code or what happens in this situation. Then once you're done, put it over here, save it in your file, use this to develop your big programs, use this to test out little snippets of code. Okay? And what else do we have here? We are way down here. We did this, right? Variables don't exist until they're assigned a value. Work through this example. I pretty much just did this for you, except I used 1 instead of 0. But do it. There's one exception to the rule that you can use any combinations of letters and numbers. Keyword. That is, there are some words that are defined in Python that have special meaning in Python. You'll learn a lot of these as we go through this class. You can't use those for variable names. So if you run into one that says invalid variable name, these are the ones that are defined, right? False, none, true, and as. You can't use these. These are the exceptions to any combination of characters, underscores, and letters. So just be aware of that. Oops. Again, you guys didn't electroshock me. Okay, if you do import keyword, right, and then do the print keyword key list, these are the variables variable names you can't actually use because they have specific meaning in Python for program control and other things. All right. We did this, did that. Mixed operators. What you'll find out is that if you have something like pi, right? There are a whole bunch of mixed operators of pi plus equals 1 says take the value of pi and add 1 to it. That plus equals say take the value of pi, add 1, and then store it back in pi. So now pi should be 4.14159, right? And you can do that with star times equal 2. You can do it with divide, pi slash equals 5, right? And you can do it with, what did I miss? Minus. Okay, so those are nice little shorthands. You're welcome to use them or not. I use them a lot because I think it makes cleaner code. You need to be able to read it. Okay, and the final thing is expressions. And all the expressions part is saying is that this is the variable, this is the expression. You can't do it the opposite way. You can't put an expression equals a variable name. That's a syntax error. All right, I didn't do any syntax errors in this. I could do something like 10 equals height. Right? Actually, I did do a syntax error. I did something that wasn't a statement. Right? This is a syntax error that won't run. Thank you. Electroshock. Okay, if I do 10 equals height, that's a syntax error that won't run. Right? If I do base area equals pi r times pi 2r, that's going to run, but it's going to give us the wrong values, I hope. Oh, I didn't save it. There we go. No, it's the same. Oh, because radius is 2. There we go. That's a syntax or a semantic error, right? The code's running, but it's giving us the wrong answer. Be able to differentiate those two. Syntax errors are generally easier to figure out. You actually have to test to find semantic errors. We have like 1 minute left. I think the last thing I want to do is just quickly hop into lecture exercises. Lecture exercises will be due at the end of as part of your next lab. These lecture exercises will be due, and we will have you, I think it's 2, 3, 4, or 2, 3, 4, and 5 will be due shortly thereafter. So work on these, get them done but don't submit them until after we've worked you through the submittee lab. It's a lot easier that way. You can, however, do these. We encourage you to do these, right? It's introduction, Python as calculator, exercises. Come down, walks you through opening up the IDE. It asks you to do a few pretty simple things. You should be able to work through these now that we've had the lecture. Just write these into a file. When we get to submittee, what we'll ask you to do is we'll ask you to upload your file into a grading system. It's pretty simple, so all you really have to worry about now is actually having that file available. So please, work through these, write the file, and you will submit this during Lab 1 in a week and a half, 2 weeks. And then from then on, you'll be expected to get these done about 24 hours after the end of lecture, or before 24 hours. Yep. This one is due whenever you have Lab 1, right? That's the whole idea, right? You had Lab 0. Yeah, you had Lab 0 already. Lab 1 is either going to be yep, that's what you just had this week. Lab 1 is going to be on 9/16 or 9/15, depending upon whether you have it on Tuesday or Wednesday. It will be due during lab. What are your checkpoints? Okay. Hold on just a second. I'm gonna. Class is over. You guys can leave. If you have questions, I will answer questions for a while.